welcome to today's maths class, and today we'll do data handling. Our learning objectives are collection and the organization of data, mean, median and mode, bar graphs, probability and the definition of various terms. Data handling is the process of ensuring that research data is stored, archived and disposed of in the safe and secure manner during and after the conclusion of the research project. We live in the world of figure. Consider the following statement. 47% population in our state consists of females. 340 of the teachers in USA are female. The enrollment of the student in the particular school has reached 1000. There are altogether 542 CBSE schools in our state. The literacy rate among men in India is 75.85. We can continue to give figures like those shown above. Have you ever wondered how such figures are collected, summarized and finally presented so that the reader can easily understand them? Numerical data can be obtained in many ways using questionnaire, observation or the interview. The data collected can be organized and summarized and presented by the means of the table, chart and graph. Next is collection and organization of data. We collected and analyzed data to answer the question or solving problem as well. Consider the following example. Suppose a sports teacher wants to know the type of sports his 40 students enjoy. So, first he collected the information. He gave each student a survey from containing the names of the sports. Each student is to select the only one favorite sports. When the counting is done, he organized the result or information or data collected in the form of table as shown below. So, here are the favorite sports and number of students. So, soccer is liked by 12 students, table tennis 6, basketball 10, badminton 7, hockey 5 and total number of students are 40. He presents the information found in the table using the diagram. See figure on the next page. He interpreted the information and draw the following conclusion. The most popular sports among the students is soccer. More than half of the class prefer either soccer or basketball. Hockey is the least popular sports. So, here he has drawn a bar graph based on the given information. So, on this horizontal axis, we have taken the favorite sports and here the number of students. So, here from the height of the bar graph you can see the most popular game, that is soccer, that is liked by 12 students, and least, that is hockey. Clear? So, by looking at the bar graph, you can find the answer of the given question. The above examples show the very simple way of collecting and organizing data. Next is mean, median and mode. The information collected by the statistician cannot be put to any use immediately and directly. So, this is called the raw data. For example, the information collected through the census and the surveys or in the routine manner is the raw data. The raw data can be presented in the form of ungrouped data, group data or the continuous frequency distribution. In this section, we shall study mean, median and mode of ungrouped data only. First is mean of ungrouped data. The mean of the set of observation of ungrouped data is equal to the sum divided by the total number of observations. The following example illustrate the use of above definition in finding the mean, also known as arithmetic mean of ungrouped data. So, I will take an example. Find the mean of first 7 natural number. So, the symbol of arithmetic mean, this is the symbol of arithmetic mean. So, we have to find the mean of first 7 natural number. So, first 7 natural number, that are 1, 2, 3, 4, 5, 6, 7. We will add them together and number of observation, that are 7. So, their sum is divided by 7, that is equals to 28 divided by 7, that is equals to 4. So, mean is equals to 4. Next is median of ungrouped data. While finding the mean of ungrouped data, we did not have to arrange the observation in any specific order. For finding the median of ungrouped data, we have to arrange it into ascending or the descending order of magnitude. The value of middlemost observation represents the median of data. Next is method of finding median. There are two methods. Method 1, when the number of observations are odd. So, median equals to value of 1 by 2 n plus 1 observation. Here n means total number of observation. We will understand this with the help of example. The runs scored by a cricket player in 11 innings are. So, these are the runs scored by a cricketer in 11 innings. Now, we have to find the median score. So, first we will arrange the score into ascending order. So, like this we have arranged into ascending order. Now, number of observation, total number of observation, that is 11, which is odd. So, median, that is equals to value of 1 by 2 n plus 1 term. So, 1 by 2 total term 11, 11 plus 1 12 divided by 2, that is 6. So, 6 term is 1, 2, 3, 4, 5, 6. So, median, that is equals to 48. Clear? Next, when the number of observation are even. So, for that we will use second method. Clear? When the number of observation that are n is even. So, median equals to 1 by 2 nth observation plus n upon 2 plus 1th observation. We will understand this with the help of example. The marks scored by 10 students in examinations are given here. You have to find the median of marks. So, first we will arrange the marks in descending order like this. Clear? Now, here the number of observation are 10, which is an even number. So, median of marks, that is equals to 1 by 2 n upon 2 means 10 by 2 term plus n upon 2 plus 1 term means 10 by 2 plus 1 term. So, 1 by 2, 10 by 2, that is 5th term plus 6th term. So, here 5th term, that is 66 and 6th term, that is 62. So, that is equals to 64 marks. That is the median mark. Next is mode of ungrouped data. Mode is the value of variable observation which occur most frequently. For example, given below is the number of absentee students in different classes on the rainy day. So, different classes and number of absentee students. Now, which is the modal class? So, mode equals to the number of observation which occur most frequently. So, here 2 is repeated 3 times, means maximum number of time. So, class 2, 3rd and 9th, that will be the model class. Clear? Next is exercise 20.1. Fill in the blanks with appropriate word. The data collected can be presented by the mean of chart, tables or graph. Clear? Practice all the questions of this exercise. Next is bar graphs. Bar graph is the pictorial representation of numerical data by the number of bars. Rectangles of uniform width with equal spacing between them. Bar graph may be drawn horizontally or vertically. We can draw many conclusions by just having the glance at them. We can draw the graph by following step given below. Step 1. We take a graph paper and draw the lines perpendicular to each other and call them horizontal or vertical axis. Step 2. Along the horizontal axis, mark the information given in the data like days, months, year, places, etc. at the uniform gaps. Step 3. Choose a suitable scale. On the scale, determine the height of the bar of the given numerical values. The figure so obtained will be the bar graph representing the given numerical data. The following example will illustrate the construction of the bar graph of the given data. So, we will take an example. The production of the scooter by a company in different years is shown follow. Here the years and the number of scooter are given. We have to draw a bar graph for the above data. Clear? So, solution. Horizontal axis पे let the horizontal axis represent the year and the vertical axis represent the number of scooter produced. So, we will take the scale. First we will take the scale. So, 1 centimeter, that is equal to 2000 scooter. So, 2000 scooter is shown by 1 centimeter. Clear? So, 8400 scooter are shown by 8400 divided by 2000, that is 4.2 centimeter. 10,000 scooter 2000 से divide करेंगे 5 centimeter. Like this we can find. So, now we will draw the bar graph. This is the horizontal axis. Here we have taken the years. On vertical axis we have taken the number of scooter produced. So, in year 2002 and 3, this is the height. These are the number of scooter. Like this, the given data we will draw the bar graph. Clear? Next is some important observation. Bar graph is the pictorial representation of numerical data by the number of bars of uniform width and equal spacing between them. The suitable scale to determine the height of the bar is also chosen, keeping in view that the space available for the diagram. The bar graph should have the title. The chosen scale should also be mentioned. Next is exercise 20.2. Mark obtained out of 100 in mathematics paper by 100 students are given following table. Here the marks are given and number of students are given. Now represent the above information by the bar graph and answer the following questions. Every student getting the highest mark entitled to get the prize of ₹10. How much money is required for distributing the prize? So, first we will draw the bar graph. On this horizontal axis we will take the marks and here the number of student. We will take the suitable scale according to given space, and according to that we will draw the bar graph and answer the following question. So, this question you have to do yourself. Practice all the questions. Next is probability. The concept of probability originated in the beginning of 18th century in the problem relating to the games of chance such as throwing a dice, tossing a coin, drawing a card from the pack of cards, etc. Today the probability has become one of the basic tools of statistics and has wide range of application in science and engineering. In probability, we deal events which are outcome of experiment. Experiments are the two types, deterministic and the random or the probabilistic. In this section, we shall deal with the random experiment only. First is random experiment. If the experiment when repeated under the identical condition does not produce the same outcome every time, but the outcome is the trial is one of the several possible outcomes, then it is known as a random or the probabilistic experiment. For example, in tossing the coin, one is not sure if it is head or tail will be obtained. So, it is a random experiment. Similarly, throwing an unbiased dice and drawing a card from the well-shuffled pack of the cards is the example of random experiment. Next is definitions of various terms. First one is elementary event. An outcome of the random experiment is called an elementary event. Consider that the random experiment of tossing a coin, a possible outcome for this experiment are head or tail. Here getting the head and getting the tail are elementary event associated with the experiment of the tossing a coin. Next is compound event. An event associated to the random experiment is the compound event if it is obtained by combining two or more elementary events associated to the random event. For example, in a single throw of dice, the event getting an even number is the compound event as it is obtained by combining three elementary events, namely 2, 4 or 6. So, this is called combining or compound event. Next is favorable elementary event. An elementary event is said to be the favorable to the compound event A if it is satisfied the definition of the compound event A. For example, consider a random experiment of throwing a pair of dice and the compound event A defined by getting 8 as the sum. We observe that the event A occur if we get any one of the following elementary event as outcome: 2 or 6, 6 or 2, 3 or 5, 5, 3, 4, 4. So, there are 5 elementary events favorable to event A. Clear? Next is probability. If there are an elementary event associated with the random experiment and m of them are favorable to the event A, then the probability of happening or the occurrence of event A is denoted by PA, means probability of A, and is defined as the ratio m upon n. Remember, 0 is less than probability of A, that is less than or equals to 1. The following illustrative example will make the concept of probability clear. So, we will take an example. An unbiased dice is thrown. What is the probability of getting an even number? So, probability of getting an even number. Total 6 numbers होते हैं, उसमें से even होंगे 2, 4 and 6. So, in all solution, the total number of elementary event, that is 6, because dice have 6 faces having the number 1 to 6. Now, let A is denoted by event getting an even number. So, even number कौन से होंगे? 2, 4 and 6. If we obtain any one elementary event 2, 4 and 6 outcome, therefore, the favorable number of elementary event are 3 out of 6. So, ratio क्या हो जाएगा? m upon n, 3 upon 6, that is 1 by 2. Clear? Here n represent the number of elementary event and m represent the number of favorable event. Clear? So, practice all these examples. Next is exercise 20.3. Two unbiased coins are tossed simultaneously. Find the probability of getting one tail. So, 2 coins, we are taking 2 coins. So, total number of outcome, that are 4. Out of that tail, probability हो जाएगी 2 by 4. That is 1 by 2. Clear? Practice all the questions of this exercise. Next is, let's recall. Multiple choice questions. Take the correct option. In a box, there are 8 red, 7 blue and 6 green balls. One ball is picked up randomly. What is the probability that it is neither red nor green? So, total number of balls or total number of observation, that is 8 plus 7 plus 6, that is 21. Out of that, we have to find it should be neither red nor green, means it will be blue. So, probability हो जाएगी 7 upon 21, 1 by 3. So, A is the correct option here. So, here we end the chapter. I hope you understand it well. Now, you have to practice it.